Good morning, ladies and gentlemen. Welcome to TechGeek webinars. Our endeavor to empower techies. We believe that sharing of knowledge is the key of enhancing our performances and for our growth as professionals. With this principle in mind, TechGeek has initiated a series of webinars conducted by industry experts to, to give you a crisp insight of various domains. Today's webinar is 20th in the series and second in the webinar series on software testing, giving insights into test analysis and design. Our guest speaker today is Mr. Amit Manohar, Software Development Advisor at Dell. Amit has over 6 years of industry experience and is very well versed with various aspects of testing technology, including test planning, test design, execution, monitoring, and control. He is a certified ISTQB test professional with experience in domains like manufacturing, e-learning, banking, publishing, video streaming, and many more. Amit is also an active member of the Indian Testing Board and loves training people on software testing. Gentlemen, this presentation will continue for the next 1 hour and will take your questions in the last 15 minutes. In the meanwhile, you can post it on techgeek.com or through the chat pane available in the webinar software. Without further ado, I introduce to you our guest speaker, Mr. Amit.
Thanks, Bharat. Hello, everybody. This session is in continuation with the test planning session that we had a couple of days back. To start with, let me first thank few of the people who have been instrumental in making my career and my professional life as a tester. First of all, sincere thanks to Vipul. Vipul is the CEO of Pure Testing. More than that, he is a brother, he is a guru. Second is my dear friend Pradeep Soundararajan. He's a very, very close friend. He is my friend, philosopher and guide and a director at Mulya Software Testing Private Limited. Satish Thakur, he is a senior test consultant at Pure Testing and is my guru. All the people at Pure Testing and testing practice guys at Dell Services, they have been really instrumental. They have been the people who are, my strength. And finally, Rex Black. This is one guy from whom I have, learned a lot through his books, through his seminars, and a lot of things. And I believe that he's one of the reasons for my success as a software tester. Let's start. Before I go into test design techniques, or before I go into test analysis and design, there is one thing that is very, very important to be learned from the test planning. Many people, when they create test plan, when it comes to writing the scope, and especially what not to test in a given cycle or what not to test in a given project, many people falter. When we are checking what are the things that are not to be tested, we must ensure that all the requirements which are not testable by testers must be covered here. For example, there are many statements in your requirement documents or in your design documents which probably will not be able to test. Let me give an example. There was a very good advertisement for a ceiling fan few years back on Indian television. It said, whatever that fan name was, ABC company's fan works for 25 years continuously. Now, my friends, when I say 25 years, that means in order to test this statement, I have to run a Orient fan or a PSPO fan or ABC fan or any other fan for 25 years, giving me a total testing time of 25 years. But what if the fan stops working in the 24th year? Do I have to fix the issue and run it again for 25 years, giving me a total testing time of 49 years? Won't my product be obsolete by then? So when we are writing this scope, we have to be very, very sure of what we are writing in that scope. What are the things that you can test? What are the things that you cannot test? So any ambiguity, any incompleteness in your statements or in your requirements must be checked there. For this particular session, I'll be taking a risk-based approach, though there are many other approaches of software testing when you are testing a product. For example, you can go for an analytical approach, you can go for a consultative approach, a regression averse approach. So there are many approaches, but I'll be using a risk-based approach, which is more generally used worldwide. These are the things that you see on your screen will be covered today. Analysis and design, we will go with identifying and designing test cases. We'll check about different categories. We'll also see What are the structural based or white box techniques? We'll see black box techniques, experience based, and finally we'll check with how to choose between these test techniques. Okay. Once our planning is finished, we go to analysis and design activities in our software testing life cycle. The first thing you will test here is you will try to review all the test bases. When I say test bases, it means all the requirement or design specifications. It can be network architecture, system architecture, quality risk. Basically, any document that helps in your testing must be reviewed when you are doing your test analysis. Based on the review of your test bases, we will evaluate testability of test bases and objects. Now this is where we will check whether I can really test test bases or an object or not. For example, if there is written in the requirements that my server should be robust enough, this is not testable. You cannot check the robustness because this is a very subjective statement. But when I say my server should be robust enough to withstand the failure of 1 servers out of 10, then I can definitely test that. I can check whether if my one of the servers fail, whether the load is shared by remaining 9 servers or not. So when you are evaluating the testability of test bases, you should be very, very clear on what is written in the requirements. If there are any doubts, this is the right time to raise those doubts. If you have any assumptions, this is the right time to raise the assumptions. Once you have evaluated your testability, what we do is we identify and prioritize our test conditions. Based on the test conditions, we will also prioritize our requirements, our objectives. We will also check what kind of required test data is used for the given test items. It can be the behavior, it can be specification or anything. Once I have prioritized my test conditions, once I have identified only identification, once I have identified my test data, I will start prioritizing my high-level test cases. Now, high-level test cases in test analysis and design are kind of a pseudo test cases. That means a test case where we will not have any test data in it. For example, for the login screen, my high-level test case can be entering a valid username and a password. User must go to the home screen or the next screen. Now I will not write test data for username and password here. During the implementation phase, I will start writing it in stepwise. Open browser, put the URL, step 3, enter username ABC, enter password ABC, expected result and all that will come under implementation phase. At the analysis and design phase, it will only be the high level test case, which is a logical kind of test case that will come here. Then you also identify the test data needed for all these conditions and cases that you have thought of. One of the most important thing is you design your test environment. Now for the people from healthcare industry, they will understand that identifying the test data, or from the financial industry, BFSI domains, they will understand that identifying the test data or identifying the test environment is very, very important. People from say publishing or people from video streaming and all other backgrounds will understand that test environment becomes a very, very important thing. Now, designing a test environment might seem not very important to most of the people, but let's say you are testing a website and the website has most of the portions written in Flash, and say people from the Flash and all this. Now, if I have to say use Flash on certain
The broadcast is now starting. All attendees are in listen-only mode.
Okay. So when you are, say, designing your test environment, typically what people do is with Flash, and once you have to work on this Flash on different browsers, say I have a configuration which is something like on XP I need i6, I need Firefox 2, and I need Safari on Windows 2, and I need to have a Flash which is say 9.0.15 or 9.0.34 or 10.0.1 or something like that. So I have 3 or 4 Flash versions, I have 3-4 browsers, and I have operating system say 98, or I have XP, then I have Vista 7 and all that. Now in order to have this kind of environment, instead of buying 3-4 machines, what I can do is I can simply take VMware into picture, put a VMware on a single machine, and put all these different configurations on a single machine instead of buying 3 or 4 different hardwares, which will be very, very costly. So it is very, very important for you to design your test environment properly. It is also important that you must know how many resources have you in place. So if you have 4 resources and you only have one machine with VMware on it, then 3 resources will not be doing anything. So how you design your test environment and how you use your resources in that environment and use your test data becomes very, very important. Similarly, you identify your infrastructure and tools that are needed. For example, the example that we have just heard, VMware became we have to I think we can still continue. It's lost the entire crowd over there. It's lost the entire crowd will be attending, but the recording and everything is re-established. Okay. Once you have identified your infrastructures and tools, you create bidirectional traceability between the test cases and the test bases. As said earlier, test bases can be your requirement documents, can be your design documents, can be functional requirements, can be system requirements, or anything. So what you do is you create a bidirectional traceability between test cases and test bases. Different phases of test development are once you have done, as I told you, I will be working on quality risk analysis. So you can see on your screen right now, there are risk analysis. Once my risk analysis are complete, we'll do a high-level test design, and finally we will do a low-level test design. There will be many inputs to all these phases. For example, for risk analysis, my inputs can be my functional specifications, my system specifications, and the outputs can be high-level test plan, a risk analysis document, and all that. All the outputs from this stage will go and work as the input for the next stage. So after I have fed up all these documents to a high-level test design, the outputs coming from a high-level test design will be my high-level test design documents, my logical test cases, my test suits, which will start coming up here. All this will go and become input to my low-level test designing, and I will have a lot of test cases coming here, a lot of test suits coming here, some test design documents coming here. Traceability obviously will be here for all the 3 phases. So I'll check with the traceability whether all my risks have been covered or not through high-level test design and through low-level test design. How we do quality risk analysis? The first and foremost is you try to identify all the risks that are there in the system. How can you do that? 3 simple ways. One, you use all the informal risk analysis techniques. For example, any risk that comes into your mind, you put it on a piece of paper and you create test suits or test cases for that particular risk. For example, I have given a lot of risks here that are, informal kind of risk: functionality, states and transitions of your system, capacity and volume, data quality, usability, UI, installation, localization, internationalization. So anything that comes into your mind, you put it on a piece of paper and you try to cover that risk using your high-level and low-level test designs. Or you can also use a formal technique like ISO 9126. Now ISO 9126 is a technique which talks about 6 major characteristics, risk characteristics of a system, and then sub characteristics in that major risk characteristics. The 6 major characteristics are functionality, reliability, usability, efficiency, maintainability, and portability. I'll repeat again. Functionality, reliability, usability, efficiency, maintainability, and portability, which is covered under ISO 9126. Or there is another technique which has come from the manufacturing sector. It is known as FMEA. FMEA is nothing but it is failure mode and effect analysis. Now FMEA talks about that you put all the risks in one area, then you try to identify the business risk and the technical risk associated with that particular risk. For example, let's say I'm creating a system which is a banking kind of system, say a credit card company where they have set up kiosks all over where you can pay your credit cards using cash or using your another debit card or something like that. Now in this case, what I have is my biggest risk to the system is this credit card bill that you are paying, and I have 2 sub-risks that I have identified. Say I have identified one risk which is related to cash and another risk related to debit cards. Now when I say cash and when I'm talking about the business risk of the cash, it is the impact on the end user or impact on the system. If this risk happens, what will be the impact on the system? So either cash or debit card, impact on the end user or impact on the bank is huge. So what I do is, for this kind of risk, I'll number this risk from 1 to 5. 1 being the highest risk and 5 being the lowest risk. In cash and debit card, both the places, my risk will be 1. Technical risk is the likelihood of that problem. Now likelihood means in this case is technically is it possible to create a system which will have check my cash and debit card properly. You see there are many counterfeit notes in the country, so it is very difficult to create a system which can understand my cash. Or I can test this kind of system by putting a Xerox colored photocopy of a currency note, say 500 rupees note, and try to put it in the system and see whether system accepts it or not. Or there are not many third-party systems available which can check this type of counterfeit notes and all that. So my likelihood of creating a system which can check my currency notes is very, very high. So my risk number with this is 1. But for debit cards, there are many swapping machines that you will see around the world being used. You might have swapped your cards multiple times. So creating a system where I can check the authenticity of a debit card is very easy. Creating such kind of system is very easy. So my risk with this system is say 5. Now what I do is I try to find a risk priority number which will be a multiplication of say my technical risk and business risk. So for cash, my technical risk was 1, my business risk was 1, the risk priority number becomes 1. But for debit cards, my technical risk was 1, technical risk was 5, business risk was 1, so my risk priority number becomes 5. Now what I can do is based on this risk priority number, I can prioritize my testing. Say all the numbers which come between 1 to 5, I do a broad testing or extensive testing. 6 to 10 I do a broad testing. 11 to 15 I'll do a cursory testing. 16 to 20 I'll do testing if time is permitted, and between 21 to 25 I will do a testing. I will not do any testing, but I will only report bugs from these areas. Now from 21 to 25 I am not doing any testing because the likelihood and impact both are on a very, very low side. So this helps you in prioritizing your risk that you have identified in the system. Now once my quality risk analysis are complete, I'll go to a high level test design, which will be creating test suites for all the quality risk categories that you have identified. Make sure that the idea here is that you must trace and cover all the risks that you have identified. So all the high risk categories that you have identified must be associated with at least one test suite that you have created for it. For example, one of the high risk categories are functionality. Under functionality, I have some sub risk categories. For example, I identified that login is one functionality, another functionality is logout, third functionality is creating reports, fourth functionality is a search or something like that. So I have created a broader or a high level risk category, which is functionality. Now high level test design says all these major risk categories that you have identified in your system, you must have at least one test suite which is covering your high level risk category. There can be more than one suite which is testing one or more than one test risk high level category. Now why we do this? Just to maintain that all the risks that we have are covered by at least one test suite. So our coverage or test coverage that you say is complete in your high level test design. Once you have say a table of suits on one side and risk categories on the other side, you will ensure with the traceability that all the risk categories have been covered with the test suite. At the low level test design, we will create a test case for sub-risk category. Idea again is that all the sub-risk categories that you have identified must be covered with at least one test case, so that you have again the test coverage of all the sub-risk categories is complete. Now in this case, let's take that functionality example again. You have a test case for login, you have a test case for logout, you have a test case for search, you have say couple of test cases for reports, you have said there are 15 different reports, you have 25 different test cases to cover these 15 reports. So it is not that you need only one test case, but there can be multiple test cases covering one sub-risk category here. Idea again is that you cover all the sub-risk categories with at least one case, so that your coverage is complete at your low-level test design. Now I'm talking a lot about this risk. So what this risk is basically, a risk is something going bad, something that is resulting in undesirable consequences. Again, risk can be the likelihood and the impact. With experience, people might mitigate few risks, but not all the risks can be mitigated. I'll give you a general life example. For example, say you are riding a bike. I'll talk about myself. I started riding a bike in 1991. So initially there was a lot of risk where I might hit people or I might met with an accident. With experience, this risk has gone down. Now I am more, I have better control on my bike. I have more confidence when I am riding a bike. So my risk of hitting other people has gone down with experience. But I used to wear a helmet in 1991. I am still wearing a helmet in 2011, even after 20 years. So my risk of meeting an accident has not gone down. So probably there might be some other Ramit who might be learning a bike today and might come and hit me. Or when you started driving a car, your risk of hitting others or meeting an accident was high. With enough experience and confidence, that risk has gone down. But you still wear a seat belt. So there are few risks that you can mitigate with experience, but there are many risks that you cannot mitigate. A product risk, say in software terms, will be something where the end product that we have created is unable to satisfy our customers or users or stakeholders. There might be a family of bugs which are behind these quality risks. So risk is very, very important. How this risk helps you? The risk helps you in reducing overall risk, overall quality risk throughout the product. When you identify and assess this risk, they help you in your test process, they help you in your test cases, in your test design activities. The more risk knowledge you have, the more answers you will be able to give about the product. Risk-based testing overall is also part of broader risk management approach. Tips: use a cross-functional brainstorming team. Whenever you are thinking of risk, always think of technical and business risk. I'm giving a lot of emphasis on and, because many people do this mistake where they only think of technical or business risk. But remember, my friends, technical and business risk has an and operator in between. So 1 and 1 is 1, 1 and 0, or 0 and 1 is always 0 here. So think of technical risk and business risk, something like severity and priority. I found this test case coverage or a traceability, a different kind of traceability. Let's see this very quickly. Here, I have specifications on one side, test cases on other side. If my test case is directly testing any specification, I have given 2 here. If test case is indirectly testing a specification, a 1 is given. You might be saying, what is this indirect testing and direct testing? For example, if I'm testing the logo of a company which is on page number 2, I might have to log in. So login is a specification that has been tested indirectly, and logo is something which has been tested directly. For the test cases which are not testing any specifications, blanks are there. So what we do is we write these 1 and 2, give totals on both the sides. Totals are nothing but just adding up these numbers. 2 plus 1 plus 1 plus 1 gives you 5. And here you can see 2 plus 2 plus 2 plus 1 plus 1 gives you 8 here. So you get these totals. Now what these totals signify here? These totals are a relative number actually. So what you do is they will give you few ideas. For example, if I see here specification 1.2 looks like the most important specification being directly tested by 3 test cases. So I can go back to my risk analysis, I can go back to my plan and check whether this specification really is most important specification or not. Or there is a specification which has 0 on it. That means this specification is not being tested by any test case. Gives me a very good idea of that I have not covered all the specifications properly. Same goes on the other side. You can see I have a 0 here. That means this test case is not testing anything. So why is it here? Or I can go to this test case and see that this test case is covering 3 specifications directly. I can check and I can go back and review this test case and check whether enough steps are there in this test case or not, so that it can cover 3 specifications directly. So this traceability gives me a very good idea of what is my coverage, and I have a relative numbers which are giving me a lot of information about test cases and specifications. Okay, when it comes to test designing, there are 3 techniques which are used primarily. The first is a specification-based technique. The second is specification-based technique is also known as black box technique, especially used at system and integration, system and user acceptance level of testing. Then I have a structural-based techniques. I can also use experience-based technique. We'll go through, all of them one by one. So let's go to specification-based techniques, and the most basic of the technique that we used under specification is equivalence partitioning. It is a kind of black box technique that is used very widely. People use it knowingly or unknowingly. This technique says that we divide our inputs or our outputs, behaviors or environments into the classes, where we divide the data into these different classes, and we assume that if one data is giving me a particular result, all other data from the same set will give me the same kind of result. We'll see some examples on this, but let's say I am creating a website which has a column age in it. A person can enter age from 1 to 99. So 1 to 99 becomes my valid set. Anything less than 1 becomes my invalid too low set, and anything more than 99 becomes my invalid too high set. So what I do is I take a number from each set and I try to test the system with this number. If that number fails, I'll assume that all other numbers from the same set will fail. So what you do is you define at least one test case from each partition. Okay. Now, as I said, this particular technique can be used for valid as well as invalid set of data, and you can have tests which can cover all your valid and invalid partitions. It can be applied to human inputs or inputs via interfaces or to systems, etc. Okay, the second technique is boundary value analysis. Now, boundary value analysis is nothing but a refinement of equivalence partitioning. I'll tell you why this is a refinement or why boundary value analysis is more used. We'll see it in the next slide. Boundary value says a lot of defects can be found at the boundaries. So for example, the same age example, if I have to test the boundary values there, my age which was 1 to 99, what I'll do is I'll take a minimum value and a maximum value and test my system with this minimum and maximum value. Plus I will test two more values. One of them will be minimum -1 and the other will be maximum +1. So in this example, my four values will become 0, 1, 99 and 100. So I'll test my system with these four values, and if there are no bugs, I'll say that yes, my system is passing as per boundary value analysis. I'll take you back to equivalence partitioning. Now my equivalence partitioning also says that if you see the first line, it says we divide our outputs, our inputs, our behaviors into classes. So let's take another example. Let's say I take a set which is 1 to 100 and I take all the numbers which are prime in nature. So prime, the lowest prime number is 2, then the next is 3, then you have 5, 7, 9 and so on, not 9, 7, 11, 13. So all the prime numbers I can put them into one set. Now in this case I cannot use my boundary value analysis on this, and that is where the catch is. So the places where you can use boundary value analysis, our refinement of equivalence partitioning, is just one place. And I'll give you an example on that as well, where we can use boundary value and equivalence partitions both. As I told you, this technique is an extension to equivalence partitioning, boundary value analysis, and you can have a non-functional boundary which can be used for non-functional testing as well. For example, if I want to test, say, the saving of a file and I want to use boundary value analysis, what I can do is I can check whether my file that I have saved, I can check how much the maximum size I can have that file as, and I can test my boundary values for that file. Or I can put all the files which can be opened in a read-only mode into one set. I can put all the files which are in writable mode into other set. So we can divide this into different equivalence partitions. Now beyond this conventional boundary value analysis, a lot of books only talk about numbers when it comes to BVA. But boundary value analysis typically is where the behavior of my the system changes. So whenever the behavior of the system crosses a boundary, I should do boundary value analysis in my system. I've given a very simple example. Say I have a text box on my screen which shows 5 characters at a time, but user can enter up to 10 characters. Then when I enter the 6th character, the system behavior will change. So I might be able to scroll between my text box. There might be a horizontal scroll bar which might come on the system. So what happens is at the 6th entering of the 6th character, my behavior of the system will change, and this is a very good example of where the boundary value analysis must be done in the system. Now, as I told you about that prime numbers, so I cannot use boundary value analysis for that prime number. So where we use this boundary values and equivalence partitions both. Okay, before that, there are many people who ask this question. Say on that age 1 to 99, if 1 is passing in equivalence partitioning, equivalence partition says 99 will also pass. Boundary value analysis says no, if 1 is passing, 99 might fail. So there is some ambiguity between this boundary values and equivalence partitions. Experience of many people have shown that you should use equivalence partitioning and boundary value analysis both, where input is in an ordered set, 1 to 10, 1 to 99, 1000 to 2000, 5000 to 10,000. So whenever you have an ordered set, A to E, X to Z, so these all are different ordered sets. So once you have, or you can take ASCII values from ASCII value 35 to ASCII value 46, these all are different ordered sets. So once you have an ordered set as input to the system, we should use both equivalence partitionings and boundary value analysis. Let's see some examples and see how this equivalence partitioning and boundary value analysis go up with. Say we have integers where we can use boundary values and equivalence partitions, 1 to 10 or 1 to 100. In first case 1 to 10, my partitions will be any number 0 or less than 0, between 1 to 10 both including, and 11 or greater than 11, and my boundary values will be 0, 1, 10 and 11. Next you have, say, systems where you are counting temperatures. And now in this case you can see that my if you see right here that I am adding or subtracting these numbers by 0.01. So my boundary values here will be minus 100.00, minus 99.99, minus 0.01, 0, 0.01, 99.99, and 100. And you can see that now I am not adding or subtracting this minimum and maximum values by minimum -1 and maximum +1, but I am using minimum and minimum minus 0.01 and max plus 0.01. Now my range is, say, from minus 99.99 to 99.99. These all become part of single set. You can divide this set further into all the negative numbers on one set, all the positives on the other set, and these both will be your valid equivalence partitions. And then beyond 100 is a invalid too high, beyond minus 99.99 becomes your invalid too low. Okay, with this temperature I always remember a question. Say today's temperature in Delhi is 20 degrees Celsius and tomorrow is going to be double hot. What will be the temperature tomorrow on double hot? Very easy, 40 degrees Celsius. Now this was not a question, this was just an example. The question is, say if today's temperature is 0 degrees Celsius in Delhi and tomorrow will be double cold, what will be the temperature tomorrow? Now 0's double is 0. So don't get confused. Change degree Celsius into Fahrenheit, get the half of that Fahrenheit, convert it back into degree Celsius, and you will get tomorrow's temperature, which will be the half of 0 degree Celsius. Strange it may sound, but here we have a half of 0 as a number which might be in negative. So as a tester, always remember that you have a solution for every problem. And as one of my friends said, if you are married, you have a problem in every solution. Okay. Next is characters and strings. So you might have password combinations here, say 5 to 10 characters, one alphanumeric, one uppercase, one lowercase, one special character, and all that. In this case, you can take a 2D XY graph and you can put numbers on one side, say 5 to 10 numbers, and you can put characters on other sides, and you can create a set of valid and invalid combinations there. Then there are few cases where validity of a input depends on some other inputs. For example, in date field, you might have 28, 29, 30 and 31 valid or invalid depending on the month you are talking about, the year you are talking about. So if I ask you as testers, how many months in a year have 28 days? If you have answered 1, is wrong. My question was very simple. How many months in a year have 28 days? All the months in a year have 28 days. There is just one month which has only 28 days in it, and might be 29 if you are talking about a leap year. Okay. Good. Some of you might have heard about this, so you might have given the right answer. Okay. How many months have 31 days? You can use your hand, the old technique, grandma technique. Yes, I got a lot of answers where people have answered as 7. Yes, we have 7 months which have 31 days. So 7 plus 28 is 1. How many months with 30 days? I got a couple of answers as 4, but 4 is wrong, my dear friends. Actual answer is 11. You have 11 months in a year which have 30 days, at least 30 days. But you have only 4 months which have only 30 days in a year. So as a tester, you have to read these requirements and then try to test these requirements. That is where, you know, a lot of tricky things happen in requirements. Same goes with time. If you have a 12-hour format or a 24-hour format, at 11:59 the next time is 12 in a 12-hour format, but for a 24-hour format after 23:59 59 you don't have 24:00:00, but you have 00:00 and 00. When date changes, does it changes at 12 a.m. or 12 p.m.? I have seen a lot of people getting confused. So date typically changes at 12 a.m. and not 12 p.m. 12 p.m. is in the day and 12 a.m. is in the night. Another example of boundary values and equivalence partitioning is currency. So it again, you have to add or subtract 0.01. Say rupee and paisa, you have to add or subtract a paisa in a minimum and maximum value. The next technique is use case. Now use case testing is where, before we go into what this testing does, use case testing is typically used when you are about to enter the UAT stage. So typically at the end of the system testing, you will have use cases which will cover end-to-end functionalities of your system. It is more of a business flows that you will test once your system is almost complete, 99-100% complete. You will have these business flows working. So this type of testing will also have end-to-end kind of approach to it. So tests are typically derived from the use cases here. If you remember use cases, they are either in a graphical representation or they are in plain English. If they are in plain English, they will have main flows, alternate flows, and sometimes exceptional flows. Example of main flow and alternate flow is I enter a username and password, both valid, matching, you go to next screen. Alternate flow, any of them doesn't match, it gives you an error screen or something, which becomes an alternate flow. Exceptional flow is, say I have a database connectivity issue, I enter my username password and my system crashes, becomes the exceptional flow. Friends, it is just an example, don't take it literally. So you have main flows, alternate flows, and exceptional flows in use cases. Use cases also have some preconditions and post conditions that have to be met in a system. For example, one of the use case scenarios I can think of is I and my wife apply for a home loan. I earn say 5 lakhs a year. My wife earns 3 lakhs a year. I have one car where I already have a loan running on that car. I have a mutual fund where I have to invest say 5,000 every month. Now in this case, what I'll do is I'll put all these inputs to the system and I will check whether my system accepts my home loan for 10 lakhs or not. So it depends that what kind of scenarios you are putting in. You can change these scenarios, you can change these use cases. For example, I make me or my wife as one of the bank employees, so the scenario will change. Or I say that I have 2 kids now, so my expenditures will change. Or instead of 1 car, I'll have 2 cars. Or I will say that my credit rating is bad, I have defaulted on my credit cards a lot of times. So all these things will change my output. Use case says you put all these things into the system and then just check whether the system is giving you a right kind of preconditions. Have you met these preconditions, and are you getting the right set of post conditions after your test cases? Helps in uncovering a lot of process flows defects when you are using these systems in the real world. Use case also helps in uncovering a lot of integration issues. The next technique is decision tables. If I take you back to your engineering days or MCA days, if you remember about truth tables from the electronics side, truth tables was typically where you will put different combinations of 1 and 0 to inputs, and you will check whether output is 1 and 0 or not. So if you have used flip-flops or you have created those electronic systems on your breadboards, we used a lot of truth tables. Decision table is typically based on these truth tables, where a decision table is shown as, different business principles which your system is adhering to. You put these under a flowchart or as tables. Let's see an example and try to gather what this decision table is. I have created a triangle decision table. This triangle decision table has come from the requirements. Say my requirements were my system accepts 3 sides, 3 integers as 3 sides of a triangle. If all the 3 sides are equal, I will get a equilateral kind of triangle. If 2 sides are equal, I'll get isosceles, and if no side is equal, I will get a scalene triangle. So based on this, I created this decision table. Now in decision tables, there are a few conditions that you give to the system. Based on these conditions, system will take certain action. In our case, it will be either an error or an equilateral or isosceles or a scalene kind of triangle, and these columns that you see 1, 2, 3, and 4, and 5, they talk about 5 different business principles on which my systems are adhering to. For example, if I enter all integers, which I enter 3 numbers which are not integers, say, or 3 inputs which are not integers, my system will straight away give me an error. Or there is a very basic rule, intrinsic rule to triangles, which says sum of 2 sides must be greater than the third side, and only then I can create a triangle. So say my inputs are all integers, but my sum of 2 sides is not greater than the third side, then I will still get an error. If all inputs are integers, sum is greater than 2 sides, and all 3 sides are equal, I will get a equilateral. If 2 sides are equal, I will get isosceles. And if all my inputs are integers, sum is greater than the second side, but 3 sides are not equal, 2 sides are not equal, I will straight away get a scalene kind of triangle. You can see here I have not written exclusively a condition here which says no side is equal. So I have just used these 4 conditions and I still get an action which is scalene kind of triangle. Now, why these decision tables are used or why they are handy? First of all, they save you from the foolish test cases. For example, if my inputs are not integers, I will not go and check whether sum of 2 sides is greater than third, or 3 sides are equal, or 2 sides are equal or not. So they save you from going to these conditions which can never be met. It's something same like you go to a bank ATM, and if your card is invalid, you don't try to check whether your PIN is invalid or not. Or to a lesser extent, many people, when I ask them to give me few test cases on login screen, they typically say enter username, valid password, valid username, invalid password, invalid username, valid password, and invalid username, invalid password. Now my friends, you cannot have an invalid password for a username which is first of all invalid. So your system will straight away check whether your username is valid or invalid, and it will go and check your password only if your username is valid. Typically, if you go to databases, you will find that username and password together is a unique key for that particular table, and only username or only password is never a unique key. Okay. Now, based on this decision table, how many test cases, I get a lot of questions on this, how you will find the number of test cases coming out of a decision table. So I'm giving you an idea. They say if all the conditions have simply yes and no to it, for example, here all the conditions have simple yes and no to it, the number of test cases will be typically in a range of 2 raised to number of conditions. So if I go back to this decision table, I have 4 conditions here. So my number of test cases will be 2 raised to 4, which is 16. But if one condition has 3 values and 3 conditions have 2 values, what I will have is 3 raised to 1 multiplied by 2 conditions with 3 conditions to it. So 2 raised to 3 giving me a total of 24 test cases. This is just a hinter. It can be plus or minus these numbers, but this is just a hinter of the number of test cases that will come out of a decision table. Different type of decision tables. One is multi-hits, all hits. Now this says where you can go back to a decision table, and now in this decision table all these business requirements are dependent on a previous business requirement. There might be a decision table where these all these business principles are independent of each other. In that case, you use this kind of multi-hits, all hits, where you get a complete result when all rules are matching, which needs to have their actions executed. For example, you can have a username and password to go to home screen. So you have all rules that must match before you go to the next action. And conditions are not mutually exclusive in multi-hit, all hits kind of decision table. Next is multi-hit, first hit. The one that we have seen is a multi-hit first hit. Now in this, you have to go from left to right and make sure that your first rule is passed, then you go to second, second is passed, then you go to third, and so on and so forth. This is known as multi-hit first hit. Again, condition columns are not mutually exclusive. And the last type is a single hit, where every combination or every combination of condition matches exactly one rule. Let's take an example. For example, I want to go and get money out of my saving banks account. So in that case, if I have the enough deposits in my saving bank account, then only then I can get money out of that saving bank account. I cannot get money from the saving bank account even if I have money in my current bank account. So all conditions or all combination of conditions matches exactly one rule here. Okay, so in this, condition columns are mutually exclusive in this type of decision table. The next technique is finite state models. Okay, finite state models are where you read the requirements and change it into a kind of graph or table to model the system, and this graph or table will give you a kind of expected results. What you do is you identify transitions, you identify events and conditions and actions in every state. Let me take you straight to a finite state model and see what a finite state model is. I have taken it from epistemics.co.uk, this particular slide. Now let's say I'm using a telephone, my phone is on hook, there is no ringing, my number is dialed, so my phone will start ringing. So phone will change from on hook no ringing state to on hook ringing state, and person at the other end rings off, my phone will come back to a state on no ringing. If I lift the receiver, I'll be on off hook conversation. From that I can hang up and phone will go back to the on hook no ringing state. Same goes with if I want to dial a number, I lift the receiver, I will go to a dialing tone state. I dial a number, system will go into a dialing state. Once the dialing is complete, system will go to a ringing tone state. Phone is answered, and then somebody hangs up that phone. I will go back to on hook no ringing state, or I can have a hang up and I can go back to no ringing state. So this is giving you a complete picture of how system is changing different states where different events and conditions are being hit. For example, number is dialed is one of the conditions. So if the number is valid, it will go into a on hook ringing state. Or if I lift the receiver, which is a condition that is being met, system will change the state and will go to a dialing tone state. How this state transition diagrams help me? It helps me where I can find a lot of design bugs. For example, if I see this state transition diagram very clearly, I don't see if I'm go and my number is dialed and my number is busy. There is nothing in the state transition diagram which is talking about a state where the number is busy. So on hook no ringing, my number is dialed, or on hook ringing or on hook conversation, another call comes in, what should happen in that case? So these things are not covered in this state transition diagram. So you can, if you can create a state transition diagram, you can find a lot of design bugs, and typically they say you find bugs as early as possible. If you can find bugs right at the design phase, it will be very easy for you to save yourself from finding these bugs at the system level, which will be a lot of expense. Bugs will be lot of expensive, and you might have to cover it right from the requirements to the system level, and thus cost of the defect will increase like anything. Okay, based on the state transition diagrams, there is another technique which is known as state transition table. Now I have used an example which is say a ATM example. My requirement says that if my card is valid, system will ask for PIN. If my card is invalid, system will give me an error. If I have enough money, system will accept the request and all that. I have created a state transition table for it. For example, say my ATM current state is waiting, where it is waiting for the customer. If a customer comes and his card is valid, system for ask for PIN, and new state will be validate state, where system will validate the card. Again, if my current state is waiting and my event is card invalid, action will be an error and system will go back to the waiting state. But there are a lot of undefined states as well. For example, if my current state is waiting and I try to enter the PIN, the action will be undefined by the system and new state will be undefined. So these undefined states is where you can go back to your BAs or your system architects and ask them what if kind of questions. What if at the waiting state I try to enter a request? What if at the waiting state I try to enter a PIN which is invalid? Which should give you, these BAs and architects will give you answers on this, and you will find a lot of positive and negative tests. Now, if I take you on the state transition diagram, how you can create a table out of this, your first state will be on hook, no ringing, your number is dialed, action will be number dialed, and the next state will be ringing. But what if, say on this stage, on the no ringing stage, you have a lift receiver and you try to do a off hook conversation, then the next stage will be undefined and new state will be undefined. So you can find these undefined states here and you can come up with negative and positive test cases out of this state transition tables. Okay. So with this we have covered our specification based techniques. Let's go very quickly to structure based techniques. We will typically talk about code coverages here, statement coverages, and then see what we can do here. Okay, structure-based techniques are where we can go inside the code. These are also known as white box techniques. Some people call them as glass box techniques, clear box techniques, because you can see inside the glass, you can see inside the code what is happening. A very typical example that I use to distinguish between white box and black box testing is that if I enter, say, on a calculator 2 and 2 and my output is 4, I don't know how this 4 came. I just entered 2 and 2. That will be a black box thing where I'm checking the behavior of the system. I know that when I enter 2 and 2, I get answer as 4, which is checking the behavior. White box techniques will tell me whether this was because of 2 multiplied by 2 or 2 plus 2. Different things that you do or different code coverages that you do at white box level is statement coverage. Statement coverage says your statements must be executed. Branch coverage, where every branch or decision is taken either ways, true or false. Condition coverages, where every condition is evaluated both true and false. Multi-condition, modified condition, loop coverages. In this session, we are going to cover statement coverages and branch coverage, and I'll tell you about condition coverage a little. Let's see an example, a simple C program for factorial. So you can see if I take you to this program, you have a main, you have int I, n and f, you enter that n. If n is less than 0, an invalid number comes out. If n is greater than 0, you go to this loop where the system tries to find the factorial, prints that factorial, returns the n, and ends the program. Now, irrespective of the kind of statements that we have, if I want to cover all the statements here, how many values of n I need to enter? So if I see this clearly, if I enter as a negative value, my statement number 1, 2, 3, 4, 5, 6, 7, 8 and 9 will get executed, and also 17 and 18. If I give another value of n which is greater than 0, rest of the statements 10, 11, 12, 13, 14, 15 and 16 will get executed, and my complete all the statements of my program will get executed. This means that I should have two values, n less than 0 and n greater than 0, which will cover all my statements. But what about decisions? If I take you little back, my decision coverage or branch coverage says that every branch or decision should be taken each way, true or false. So in this case, how many decisions I have in this program? Yes, I have two decisions. One is if, else, and another is this decision where I am checking I is less than equal to n or not. Now, if I give a value of n which is less than 0 and a value of n which is greater than 0, my true or false of if will be checked, but not of I less than equal to n. You can see, if you clearly see this program, to enter and check the false side of this particular decision, you must have a value which is not less than 0 and not greater than 0, and you can check the false side. So in this case, we also need to have a value of n which is equal to 0 to check the false side of I less than equal to n or not. So for branch coverage, I must have three values, n less than 0, n greater than 0, and n is equal to 0 to check both the sides, true and false sides of all the branches or all the decisions in this program. There are no multiple conditions or compound conditions, so you don't need to check condition coverage here. But I will tell you this condition coverage. Loop coverages. So you can see there is one loop here, for loop. To do the loop coverage, you have to cover this loop by giving 1 as a value where you go inside the loop and cover it once, and you have n as max values. So you try to give a value of n as max, and then you come up with you go inside the loop and you cover this loop by running the loop maximum times. And this loop coverage is important because a lot of programs, the more you run into these loops, system sometimes goes into infinite mode, or memory usage or resource usage increases, and then the performance degrades. So must be tested with n is equal to 1 and n is max. Let's see an example on condition coverage. My branch coverage says that you test, or decision coverage says branch and decision is synonym. So my decision coverage says that you should check the yes and the no side of a decision. I have taken, say I am creating a matrimonial website, and in order to check whether a female can marry or not, I have two conditions: gender is female and age is greater than 18 or less than 18. If the gender is female and age is greater than 18, then and only then a female can marry, otherwise it is always no. My decision coverage says that I must test this yes side, and I might use any of these three, any one of these three inputs to check the no side of a decision. My decision coverage will be complete. So this particular case where I have to check whether the gender is female and age is greater than 18, and my answer is yes, and any one of these three rules where I can have a gender male or female, or I can have an age less than 18 and for a male greater than 18, and my answer will be no. Condition coverage says you simply do one step ahead, you cover all the things that are coming in this table. This is my condition coverage. So this simply says that if I do 100% condition coverage, my 100% branch coverage will be complete. And we have also seen that if we do 100% branch coverage, our 100% statement coverage will be complete. So the best possible thing that you can do is you do the condition coverages of your codes that are coming up. Okay. So with this, white box is complete, and let's go to experience-based techniques. Experience-based techniques are where the tester's skill and intuition comes into picture, or tester who has tested the similar kind of applications or similar kind of technologies. People who have strong domain experience come into and test a lot of systems based on their experience. For example, whenever I start testing with numbers, the first number I enter in a system is 666, which is known as a devil's number. I don't know why I started doing it, but the time I started using, testing these numbers, the first project that I worked on, the first time I used these numbers, I just had seen a movie called The Omen, where they had a large, these 666 numbers, and they were talking a lot about the 666. Somehow I started using this number. So I always typically start with 666. I always have an intuition that I will find a lot of bugs if I start with this number. I don't know why. And typically I follow this 666 with two more numbers. One of them is 999 and the third number is 333. So my intuition says I will find a defect. Or you might have seen that a lot of people find defects around dates where they enter 32 as date, or 29 to 30 or 31 is a date for the month of Feb, and they typically find bugs. If the coder has written his own code for the calendar, you might find bugs there. Or there are people who are in a banking domain, or who are in publishing domain, or any other particular domain for 6-7 years. You don't need to tell them what are the areas where you need to test it or you need to find defects. They will typically find defects because they have experience with same kind of domains. Rather than pre-designed, experience-based testing is where test cases or test design and everything is created dynamically while you are executing your test cases. So your overall documentation is on a very, very lower side. Tests are frequently time-boxed, or experience, there are many people who are doing session-based time management now on these experience-based techniques, where you create a session, you give an objective to the session, and then you write what have you tested, what were your findings, what were the different things, or the workthroughs that you have followed, workflows that that gave you problems, workflows that were smooth, or are there any workarounds for the defects that you have identified? The documentation is typically on a very low side here in experience-based techniques. Many people use different ways to do experience-based techniques. For example, there are test charters that you might follow. There's a bug hunting approach, or there is a checklist that you might have created, or there is bug taxonomy that you might have used. Exploratory testing. My friend Pradeep Soundarajan is a great expert in exploratory testing. Context-driven school of testing, so they all can be used in experience-based testing. Advantages: these strategies, experience-based techniques are very good in finding defects. They resist pesticide paradox. They are good on prepared test cases. They are fun and creative, but the problem is coverages are typically very gappy if you are especially under pressure, or there is no bug prevention and only bug detection in these kind of techniques, and not all testers have necessary level of skill and experience. The last thing, what factors you need to choose when you are choosing any technique. So it depends what kind of system you are testing, what kind of regulatory or standard compliances you are talking about, what are your contractual requirements, what is your knowledge of testers, how good your testers are, what is your time and budget, what kind of development life cycle you are using, what is your experience or type of defects that you have found in previous projects. They all come into picture when it comes to the factors that you have to choose your techniques. So with this, our test analysis and design is complete. You can contact me on my Gmail ID, which is ramitmkaul, RAMITMKAUL @gmail.com. No spaces here. You can also write to me at Ramit_Manohar@Dell. You can write to me at Ramit@Indian Testing Board. My Twitter handler is @RamitMkaul. You can also find me on Facebook and LinkedIn for all your questions. Since we have run out of time, you can send me your questions. You can either mail me your questions, or you can write your questions on TechGig webinar link, and we'll try to answer your questions. Okay, so thank you very much for listening to me very patiently. Back to you, Bharat.
Thanks, Mr. Amit, for your session on test analysis and design. It was indeed an enlightening session. I would like to thank our participants for their support in making this webinar a huge success. The recording of this webinar will be made available to you on techgeek.com by tomorrow. Thank you.